This is the 2018 FRQ BC number 5. So we're given two curves. One's just a circle, okay? So with a radius of 4. I will label that. And then this other one, we're given this shape. Might be a cardioid or something. I'm not sure the name. But those are our two functions. In fact, let me kind of highlight this with blue so you can kind of see which one's which. The other one I will draw in red. It's just a circle. Oh, you know what? If I do this, it should make me a circle. Bam. And let me hollow that out for you guys. No fill, no fill. Wait. No fill. And this I want to make red. Okay. And let me relabel this. R equals 4. So part A, they want R, that shaded region. So the way I'm going to do this, I'm going to take the area of the red part. Let me draw that out for you. And then I'm going to subtract the area of the blue part. And remember, areas in polar form are through angles. So I'm going to start with that angle. And basically, you find the area through these angles, and it's going to stop there. So my starting point, and they tell us that's pi over 3, and they tell us that's 5 pi over 3. So the area of the shaded region is 1/2 integral from pi over 3 to 5 pi over 3. And to make my life easier, I'm going to define something. At some point on the test, I'm going to say let R1 equal this one. That way I don't have to keep writing it out, but I guess it doesn't matter because this is actually not a calculator. I'm going to have to work this out, so I'm going to just leave it. 3 plus 2 cos theta r squared d theta. So that's the area of the red. And here's the problem. That includes all of this area. Oh, I just messed up. I liar, pants on fire. Because the radius of the red is just constantly 4. So that's just, sorry, that's going to be r squared d theta. Now, all of this stuff here shouldn't be included. That's not part of the shaded. So that's actually the area inside of the blue. So I have to subtract the blue portion. So the blue portion, again, areas are mapped out at an angle. So we're going to start at that angle and just keep on going, increasing our angle until we get to our ending angle, which is there. So that one, excuse me, subtract that, it's 1/2, and I start at pi over 3 also. I end at 5 pi over 3, but that's going to be r 3 plus 2 cos theta. So that's my r squared d theta. So that answer, we don't have to actually calculate it. It just wants an expression. That answer is perfectly fine. But since we have the same limits of our integration and they both have a half, we can rewrite this as one integral and combine them together. I don't necessarily recommend this, but it's prettier. So that answer is also acceptable for part A. For part B, I think we're good. Find the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta at theta equals pi over 2. So part B, I will do down here. dy dx is dy d theta over dx d theta. So that is something we did with the previous section in chapter 11. My brain just went blank. The parametric form. So if I can get this in parametric form, I'm able to calculate this. So x is r cos theta. So I'm going to do that. R cos theta. And y is r sine theta. Now, when you do this, all of a sudden you have converted a polar form into parametric form, and everything you did with parametric form works with the polar form. So it's kind of nice. So since this is a non-calculator question, I have to show my work. So I need to find the derivative of x with respect to theta. It's a product rule because I'm multiplying two things together. So I leave the first alone. I take the derivative of the second, and then I take the derivative of the first, which would be minus 2 sine theta, and I leave the second alone. Kind of scrunch myself there. Then I do the same thing with y. I take the derivative of y, product rule. I leave the first alone. I take the derivative of the second, and then I take the derivative of the first and leave the second alone. So I'm almost done here. So I want the slope at pi over 2. So let me create some space here to write on because I'm out of white space. And let me fill this with white and do that. So I need dx d theta at pi over 2 and dy d theta at pi over 2. So I'm going to just do that here, dx d theta at pi over 2. So we're going to plug a pi over 2 here. Cosine of pi over 2 is 0, so that's just going to be 3. Sine of pi over 2 is 1, but it's negative. But cosine of pi over 2 is 0, so that's not even going to be there. So we have our answer of negative 3. Then we do the same thing with dy d theta. So anything with the cosine is going to be 0 because cosine of pi over 2 is 0. So that will be 0. And we're left with this. Sine is 1. That's 1. That's 1. So we end up with negative 2. So then I can say dy dx at theta is pi over 2 is going to be dy d theta at theta is pi over 2 divided by dx d theta at theta is pi over 2. And we did those. So it's going to be negative 2 over negative 3, which is 2/3. And there is my answer. Okay? And we'll make sure I answer the question. Find the slope of the line tangent. If you want to say the slope of the line tangent of the graph r equals 3 plus 2 cosine theta is 2/3, you can do that. All right, let's keep going here. So we have one more part. We're almost done here. Part C. And I'm going to erase all of part B, I think. Let me make sure I don't need it. Part C, a particle moves in the portion. So the particle is moving on the blue graph, starting at 0 and just moving along the graph like that. That's what it's saying. The distance between the particle and the origin. So let's break this down. The distance between the particle and the origin increases at a constant rate of 3. The distance between the particle and the origin is r. So what that is saying is the rate of change of r is 3. And it's increasing, so it's going to be a positive 3. And then find the rate at which theta changes with respect to time. So that's saying find d theta dt when, they gave a specific time, when theta, wow, didn't want to do that, when theta is pi over 3. Let's see. Let's read this again. There's more information I need. The particle moves along the portion of the curve. The particle moves in such a way that the distance between the particle and the origin increases at the rate of 3 units per second. Find the rate at which theta changes with respect to time at the instant when the position of the particle... Okay, I think we can do this. I really don't think we need any of this part B stuff, so let me erase all that. Excuse me. this. And let me make a box, and we'll be ready to go. Okay, so to summarize, what do we have? We have dr dt. We're trying to find d theta dt. All right, we have a problem. So we also have this. R equals 3 plus 2 cos theta. Let me clear my throat, excuse me. Okay. So I want d theta dt. I have r's and t's. What can I find here? I can find r's and thetas. I'm able to find dr d theta, and that's going to be minus 2 sine theta. So look, dr d theta, dr dt, d theta dt. So these have r's in commons, these have t's in commons, and these have thetas. So they're all going to tie together. Here, it doesn't matter which way you do this, but I'm going to start with dr dt. With that one, I know it's 3. So I want a dr on top. Here's a dr on top. So I'm going to make that dr d theta. But I want a dt on the bottom. Well, there's a dt on the bottom. So I'm going to make that d theta dt. And if you look, that matches up, right? Because of d thetas. So that's using the chain rule. So let me back up here. All of these I want at pi over 3. So I'm going to do that. Theta is pi over 3. Try to squeeze that in there. So this is 3 because it's constantly 3. So we're going to put that in there. Dr d theta is negative 2 cosine at pi over 3. So I took dr d theta and I replaced theta with pi over 3. And d theta dt is what I'm looking for. And I will do this another way for you also. D theta dt at theta is pi over 3. Cosine of pi over 3, I can do that. Cosine of that is 1/2. So these cancel, leaving negative 1. Multiply both sides by negative 1. I get negative 3. Something's not right here. Let me think. Oh, whoa. Back up. I put a wrong thing here. I knew something wasn't right. Dr d theta is sine. I put cosine. What a lame-o. So that's sine, and sine is radical 3 over 2. So I get radical 3. Divide both sides by negative radical 3. But that is the same thing as negative radical 3. Rationalize, multiply by radical 3 over 3, you would get negative radical 3 is your d theta dt at theta is pi over 3. Okay, I'm going to show you another way to do this. Basically the same thing. We're just going to do things slightly differently. So let me erase all this. And this might make more sense to some of you, and you might like this better. Uh-oh, I lost my box. Can I undo that? I think I'm going to erase this different so I don't lose my... Oh, I lost it anyways. That's not helping me. This is going to take... Yeah, I'm just going to erase it and put a new box in because this is not pretty. Okay. So this might be more intuitive. You want d theta dt. That's what you want. So there's my d theta, but it's the wrong place. So I'm going to reciprocal both sides. d theta dr is 1 over negative 2 sine theta. Now I have d theta on top. So that's good, that matches, but I want dt on the bottom. Well, there's a dt on the bottom, so I have a dr dt. And again, it works out nicely. These cancel out, right? So d theta dt at theta is pi over 3. I can do that. So d theta dr, that's right here. That's going to be negative 2 sine pi over 3. Oh, it's 1 over that, sorry. 1 over that. And dr dt is constantly 3. So I multiply that by 3. Sine of pi over 3 is radical 3 over 2. Those cancel. And so we get negative 3 over radical 3, which is negative radical 3. So that's the other way to look at it. And that's the end of this problem.